This second video for chapter 3 is a revision of logarithmic laws, or log laws. Definition of a log here, and important to note there that if you've got something in index form, its conversion to log form looks something like that. So if n equals a to the power of x, okay, then n there equals a to the power of x. Right, so I always in my head form logs by going a to the power of x equals n. Okay, and that switching between index and log form is something that needs to become automatic. Okay, and pretty quick. All right. Okay, so other thing to remember is that logs and zeros don't mix. Okay, you can't get a zero in that position, you can't have a zero in that position. Okay, so just keep an eye out for that. Okay, sometimes people get confused there. Okay, now a bit of definition here. The a there, okay, with logs is called the base. Okay, so if we had something like log expression like that, we'd say that's log, that's what I'd say, inverted commas, log 8 to the base 3. So, I'll certainly be using the language. I want you to use the language. Don't say something like log 8 3 or log 3 8. It's log 8 to the base 3. Okay, try and get used to that sort of language. All right, log laws, which I know you've seen before. So we'll just do a quick brush up of it. Log 1 to the base a equals 0. And why does that come about? Because if we convert that to index form, we know that a to the power of 0 equals 1. Okay, so if 1 is in that position there in the log expression, it doesn't matter what the base is, we're going to get 0 there. Log a to the base a, okay, equals 1, and that stands to reason too, because a to the power of 1 or anything to the power of 1 equals the same expression. So if you've got 10 and 10 there and there, for example, you're going to equal 1. Log 10 to the base 10, log 5 to the base 5, etc. When you've got two log expressions multiplied with the same base like that, you can separate them out and add them with the same base. So an example of that, if I've got log 12 to the base a, that's the same as log 3 to the base a plus log 4 to the base a, because 3 4s are 12. Same works with division. If you divide two numbers with the same base, you can subtract the two expressions there. This is a big one, and you've seen this before. Sometimes these brackets aren't drawn in, but log mp to the base m to the power of p to the base a, the p can flip out the front. So if you've got log a to the 7, log 7 to the base a, and the 7's raised to the power of 3, the equivalent of that is 3 log 7 to the base a. Okay, so that movement of the index to the coefficient and vice versa comes up a lot. Last rule here, which doesn't come up much in our course, but I've included it, is the change of base rule there. Alright, trying to do some problems here. And first of all, these involve the log rules, and I mentioned that if 1 is in that, if 1 is in that position there, that the answer is always 0. Okay, now how do we know that? Because 2 to the power of 0 equals 1. So evaluate that, that is the answer, it equals 0. Mentioned before, if those two numbers are the same in the log expression, that equals 1. Write in index form, the base to the power. Okay, in index form, 2 to the power of 3 equals 8. This one, it would be, I shouldn't have that equals there, sorry. This one, change to index form, x to the power of 4 equals 81. Simplify it. Now, here we're going to use the rule, actually, sorry, Might just use that. Use A to start with here. You saw a rule a little while ago, and I'm sure you're familiar with. And it can work both ways. The rule I had the other way worked the opposite direction, but it still works the same. So if we apply that rule that we saw before to this situation here, then that's the same as that, because 5 2s are 10. M times n. 5 times 2 equals 10. And of course we know that that equals 1. Next one, that's going to be the same as, you can miss this step out if you wish, but I want to just show you how it works here. When we subtract two log expressions with the same base, we can divide to the one base there, to the 4. That then is log 4 to the base 4, and that's 1. Okay, simplify this one. Okay, 2 to the power of what equals 16. Answer 4. What an extra step in this one, because the fifth root of x, is the same as x to the power of 1 over 5. Okay. And that equals 1/5 log x to the base 5. Okay, by taking the 1/5 out the front. Right, next one, we've got an addition. We've got the same base. That's the first thing to point out here. Okay, we've got 3, we've got 3, and we've got 3. So I'm going to do one rule at a time here. So what we've got is, if I look at the first two situations, I can say that 27 times 9. Remembering, if we've got the addition of two log expressions with the same base, we can combine them into 27 times 9. Now we're subtracting here, so we can put there over 81. Now I could do this in two separate steps, but it might be just as easy to do it in the one step there. I can do some cancelling now. 9 into 9 goes once. 9 into 81 goes 9 times. So that's going to be log base 3, 27 times 1 is 27 on 9. Then in brackets, equals log 3 to the base 3 equals 1. One thing I just want to point out before we go any further, and I should have mentioned this earlier in this video, is that when I do something like this, when I'm writing it out, the 3 is of a normal size of the log expression. That 3, the 3 that's the base is clearly set down below, like it's a subscript, and it's clearly smaller, about the half the size of the other 3. So please don't get lazy and sort of do this, all right, where you can't tell whether the 3 is the base or not. All right, make sure that it's clear where the base is here. It's half the size of the other number. All right. Next one, 2 plus log 10 to the base 3. Now, there's a few ways of going about this, but one way is to convert the 2 to log base 10. Okay, so how do you do that? Well, to do that, we've got to think, well, if I put a base 10 there, 10 to the power of 2 equals what? 10 squared is 100. Okay, so I can convert whole numbers to log expressions in that way. So let's just look at that, if I went a bit fast with that one. So we're converting 2 to something that's got a log of base 10. Okay, how do I do that? 10 to the power of 2 is 100. So that's how I got that there. This one here is already base 10, so you'll see why I've done that. Okay, then I can combine them, which is the rule that you would have seen last year that says if we add two expressions with the same base, we can multiply. So that's going to be log 300 to the base 10. Okay, and we can leave our answer at that, as that. Next one. Now there's a couple of ways of going about this. And we'll have a look at this next question more. Next one's a bit tricky. What I'm going to do here is I'm actually going to take out a common factor. So I'm going to take out 3, because you can see there's a 3 there and a 3 there. Log 6 to the base 3. I'll just drop the brackets for the moment. And log 18 to the base 3. So I've taken out a common factor. Then, inside that bracket, I'm going to apply the rule that says if I'm subtracting, I can divide, like so. Now it just so happens that 6 on 18 is 1/3. Alright. And I'm going now to make the 1/3 into 3 to the power of -1. Continue over here in this next slide. So remember the rule that says if we've got an index there, and I'll just use a red pen now, with our index there, we can put it out the front. So the -1 can go to that position there, get multiplied by the -3, and I get -3 log 3 to the base 3. That's 1. So it's -3 times 1, which is -3. Last question for this video is this one. Log 9 to the base 3 over log 27 to the base 3. Pretty simple one, this one. Log 9 to the base 3. 3 to the power of what equals 9? 2. Over 3 to the power of what equals 27 is 3. So the answer there is quite simply 2/3. Okay, so that's it for an introduction to logs. You can now have a go at exercise 3B.